Hello everyone. I'm going to talk about our work on debunking fake news and false claims using evidence-aware deep learning. And this work is done jointly with my current and former colleagues at MPI. So in the recent time, we have been witnessing some serious impact of misinformation on the web. In fact, this rapid spread of misinformation is identified as one of the top 10 challenges by the World Economic Forum. To solve this problem to some extent, there have been many fact-checking websites online these days, like Snoops, PolitiFact, etc. However, to cope up with the speed and the scale at which this misinformation spreads, we need some kind of tools to automate this process. So the focus of our work is to automatize this manual verification process. There are mainly three sets of related approaches around this problem. The first one is the truth-finding approaches, which essentially try to resolve the conflict among multi-source structured data. However, these approaches are only limited to the structured data. The second set of approaches do credibility analysis in communities and social media, but these approaches are focused only on the close communities, and most of the times they rely heavily on the community-specific features like number of retweets or number of likes, etc., which are difficult to generalize. Recently, there have been also new approaches which do credibility assessment for the natural language claims in an open domain setting. However, these approaches either do not use the external evidence or rely on the substantial feature modeling. So in this work, we try to address these limitations of the prior approaches. Now, let's look at the exit problem statement, which we are working on. So given the textual claim and its source, we build an automatic system, which we call it as DeClarE, which assesses its credibility and tells how likely it is true or false. And along with that, we also want our system to give the user interpretable evidence in the ends, which support the automatic assessment. Now, you may wonder, what are these textual claims, right? So here are a few examples. The first one is from Tucker Carlson, who is the news reporter at Fox News, saying that far more children died drowning in their bathtubs than were killed accidentally by the guns. The second one is from the conservative flashnews.com website, saying that Obama ordered a statue of himself to be installed in White House. And the third one is that the original name of the Diet Coke, which was TAB, took its name from the acronym for Totally Artificial Beverage. So, well, the first two claims are false for sure, but I'll leave the third one as a quiz to you guys. If any of you can figure that out, you get a free Diet Coke after this session. And now you may wonder, what kind of evidence are we expecting out of the system, right? So here is an example for the claim about Obama ordering statue of himself. We have two articles from the abcnews.com and the Florida Times describing about this claim and denying it, straightforward, that these are the false rumors going around the web. So this is something which we are looking out of our system. Okay, so after the motivation and the problem statement, here is the overall outline of my talk. First, I'll talk about the key contributors, and then talk about the network architecture and the approach which we use. And finally, I'll discuss about the experiments and the results. So we propose 4 key contributors. The first and foremost is to consider the external evidence. So the idea here is that apart from considering the text of the claim, we also want to consider various web articles which talk about this claim. The second is to capture the language style and the semantics of this evidence article. And the hypothesis here is that if some subjectively written article is talking about some claim, then it is likely to be false, versus some objective article is supporting some claim. And for that, we use bidirectional LSTM. And third is to capture the interaction between the claim and the evidence article. For that, we propose an attention mechanism which captures the importance of each term in the evidence with respect to the claim text. And the fourth and the final one is to capture the trustworthiness of underlying sources. For that, we try to learn the embeddings of the source and the claim evidence. Okay, so coming to the approach, we have 4 sets of inputs in our model. We have the claim and the article representation, which we represent as the set of a sequence of word embeddings, and then we have the claim and the article source, which we represent as DS dimensional embeddings. Now, to get the language style aware representation of the article, we pass the article through a bidirectional LSTM, where each term in the evidence article is represented by the hidden state output coming from the bidirectional LSTM. Now, as we discussed, we also want to capture the importance of each term in the evidence with respect to the claim. For that, first we take the overall claim representation by taking an average of the claim word embeddings, and then we append this claim word embeddings with the individual article term embeddings. Then later, this appended article embeddings are passed first through a dense layer and through a softmax layers to get the attention weights. And these attention weights signify the importance of each term in the evidence with respect to the overall claim representation. Okay, so now we have two things for the terms present in the evidence. We have their attention weights indicating their importance with respect to the claim, and we have the hidden state representations coming from the bidirectional LSTM. So to capture the overall representation of the article, we multiply these two and take an average, which gives us the overall representation of the evidence article. Now, to get the credibility score, first we append this article representation with the claim and the evidence source embeddings, and then we pass them through two nonlinear dense layers, and then through a softmax or a linear layer, depending on the end task which we are trying to achieve, to get the overall credibility score of the claim. So this is the overall system network which we use for our approach. Now, coming to the experiments, we perform 4 case studies on the real-world datasets, and we do a bunch of analysis on the outcome of our model to understand why it is performing in certain way. And in the interest of time, I'll only talk about the first 3 experiments and the first 2 analysis which we did. For Snoops, we have roughly around 4,300 manually labeled claims, and for PolitiFact, we have roughly around 3,500 manually labeled claims. And here are some examples on the right-hand side, which typically are verified on Snoops and PolitiFact. And to get the set of evidence article, we fire the claim text as query to the search engine, and then get the first 30 top search results and use them as the evidence article. Now, to compare the performance, we use very recent baselines, 3 recent baselines. And it should be noted here that the first 2 baselines here, they do not consider the external evidence. They rather use only the text available in the claim to predict its credibility. And the third baseline is our prior approach, which requires a substantial feature modeling, and it also relies on the handcrafted, very rich set of lexicons, depending on the language style and subjectivity, etc. Now, as we can see here from the results, for Snoops, our approach is slightly behind the distance supervision-based approach. However, the advantage here is that without relying on the rich set of lexicons and the feature modeling, we are achieving the similar results. On the other hand, for DeClarE, for PolitiFact, we see that our approach improves the performance over the other 3 baselines. For the next case study, we consider the News Trust dataset. News Trust is basically a news review community where the community members verify or review news articles which are there on the web. And each story in News Trust contains an article to be reviewed and where it is coming from, for example, bbc.com or any other website. And it has a bunch of user reviews, which are the member of the community, writing their reviews and giving a rating on a scale of 1 to 5. To use this data in our setting, we use the title of the article to be reviewed as the claim text, and the article where it is coming from, the article source, we use it as the claim source, and the user reviews and the user identities are used as the evidence and the evidence source. And the end task here is the regression task, which is to predict the credibility score of the news article which community members are trying to review. Now, coming to the results, since this is a regression task, we report the mean square error. And as we can see here from the results, our approach clearly outperforms the other baselines by a big margin. Okay, so now coming to the analysis part, first we wanted to analyze the source embedding, article source embeddings in the Snoops dataset. And for that, we plot this article source embeddings into 2-dimensional space using PCA. And we see here very interesting results. So as we can see here, our model is able to clearly separate the websites which are very well known for being nasty and propagating all the fake news like Empire News, National Report, versus we have the bunch of websites which are very authentic news websites, New York Times, CNN, etc. And similarly, we also wanted to analyze the claim source embeddings for the PolitiFact dataset. And again, here we see that the politicians which are having the similar kind of ideology are clustered together by our model. And as we were discussing, the attention weights also help us to understand the importance of each term in the evidence with respect to the claim. So to give an example, here is the first claim by Barbara Boxer, saying that Florina's plan would slash the Social Security and Medicare policy. And we have the evidence coming from the NewYorkTimes.com. And the words are highlighted here based on their attention weight. So the darker the shade, the higher the attention. And as we can see here from the result, the words highlighted like glimmer of truth or barely true claims, sketchy evidence, etc. These help us to understand why this claim was predicted as false. And now comes the quiz part. So if anyone guessed it, I mean, most of us would like to see this claim as true, but unfortunately it's false. And Coca-Cola didn't get its name from totally artificial beverage. So we have the other evidence coming from the Fox News website denying that this was like a rumor and it wasn't true. Okay, so to conclude, we propose an end-to-end neural network-based model which does not require any feature modeling and which also provides interpretable evidence in the end, supporting the automatic assessment. And experiments on real-world claims show the effectiveness of our approach. And one of the key outcomes of our study here was that the considering external evidence really helps. So rather than focusing only on the claim, we should also look for the external signals from the web, what people are talking about that and how they are reacting to certain information. And we have also made the data sets available publicly, so feel free to use them for your research. And now I'll be happy to take any questions you have. Thank you so much.
Thank you. All right, it seems like with every talk we have a little more time for questions. We have 6 minutes. So again, if you would like to ask any questions, you can line up at the microphones and ask. All right.
Hi, thanks for the great talk, and I have a question, which is, you showed the analysis on the embedding for the source, and you showed that the fake news are clustered together, but I guess that's exactly what people do not really want, because whether a claim should be identified as a rumor should not dependent on who claims it, but it should be dependent on what is actually like the real world evidence. So what do you think about this?
Yeah, I mean, it's a good point because this also came up when we were attending this workshop, Fever. So where Full Fact, there was a talk from Full Fact which mentions that they really want to be politically neutral and don't really look for the source of the information where it is coming from. But I mean, which is true, but in my opinion, it's also very hard. So even for the humans, when we come across certain information from certain people, we start creating certain bias or the trust. Now, when the president tweets something on Twitter, then half of the times we believe that, no, it's rubbish, right? It's not useful. So these kind of biases are there, it creates, but it's a good point. We haven't looked into it, but something which we will surely consider doing it. Thank you so much. Yeah.
My question's about the search engine to retrieve the evidence.
Yeah.
Have you analyzed what was being retrieved? For example, if these are well-known, like fake news type of sentences that you're putting into the search engine, you're going to find maybe websites that are already debunking the claim in your 10 or so retrieved articles. But if it's something new, a new claim that nobody's debunked before,
yeah.
What does it generalize to?
So that's a good point, but like to be neutral in our experiments, the popular fact-checking websites, we remove them from the data set, so we filter the articles coming from Snoops or PolitiFact. But nowadays, because of the nature of the problem, there are also mainstream news websites which also talk about the misinformation. So then it becomes really hard to filter the websites and all. And in the end, we are looking for evidence, right? So if we are ignoring all the evidence where people are supporting something or refuting something, then we have nothing apart from the claim text, and we go back to the same problem.
Hi. I have a follow-up question to the search engine. So how many results do you get back? How many do you keep them in your model to compare the embedding similarities?
So a number of articles, you mean?
Yes.
Yeah, so I mean, we try to get the first 3 pages, and then we also have a post-processing step where sometimes because of the high recall of the search engine, we may get certain articles which are not really relevant to the claim. It's just that few words are matching with the article and the query, they are coming as a retrieval result. But then we do some post-processing and really make sure how many articles are really talking about the claim, and then we also try to extract the snippet out of the article. But we address that, so for more details I would recommend reading the paper, or we can discuss later on.
Okay, thank you.
Thanks.
The question here.
Hi, I'm Dwayne from Columbia University. So really interesting work, but one question which I wanted to ask, I mean, I guess you're aware of the fever shared task and the fever data set. So then when you say that you retrieve the evidences, how do you basically verify that the evidences are actually correct? Because like for the fever data set, the evidences are also selected by annotators, and it's kind of pretty hard to match the evidence selected by the annotators. So then if the evidence which your search engine is selecting, if that's not correct or that's not very appropriate, then your model is kind of biased in your results, right?
Thank you for bringing this point. I mean, in the interest of time, I couldn't go through that slide, but as I was talking to the other questioner, once we have the article, we don't use that article straight away. We chunk that article into a set of snippets, and then we have certain kind of heuristics, which also considers the overlapping words between the claim and the snippet which we extract from the article, and also the semantic similarity. Of course, it's not as perfect as someone manually constructing the evidence out of that, but we have certain checkpoints to make sure that what we are using is not completely useless with respect to the claim.
Okay, we have time for a quick last question and answer.
Okay, thanks for the talk. I guess for this problem, time matters a lot. So obviously these models can only be trained on past data, but actually in inference time you want to predict, let's say, for a statement for Twitter tweet, which is just kind of published now. Did you ever look on this topic?
Yeah, not in this work, but in our previous work, we also tried to consider the trend, how their opinion towards certain things change over a period of time, and if we can capture that, but not in a deep learning setting, which we have kept it for the future work, but it's certainly an interesting point in the time aspect. Thank you.
Thank you. All right, let's thank the speaker again.
Thank you so much.